Let's take a look at this problem. It says the age distribution of the Canadian population and age distribution of a random sample of 455 residents in the Indian community of Red Lake Village are shown below. And looks like we're given some percents and we're given some observed values. Okay, so our categories. We got under 5, 5 to 14, 15 to 64, and 65 and older. Okay, now our percent is this is 7.2%, 13.6, 67.1, 12.1. And our observed is 47, 75, 288, and 45. Okay, and it says use a 5% level of significance. So alpha is 5%. To test a claim that the age distribution of the general Canadian population fits the age distribution of the residents of Red Lake Village. Okay, now notice what these columns are. This percent here is the Canadian population. That's what this age distribution, they believe, like, for example, 7.2% are under 5. They believe 13.6% are from 5 to 14. Now what we're wanting to do is we want to compare the actual number in this Red Lake Village with the Canadian population. Okay, so test claim the age distribution fits the age distribution. Okay, so the percentages we're given here, the proportions, I'll say percentages, fits, okay, are the same. So we're saying Red Lake Village right here has the same breakdown as a Canadian percentage here. So that's everything they give us. So let's go to the PowerPoint. Write down a shortened version of the claim. We did that. Percentages are the same. Come up with a null and alternate hypothesis. And this says H0 has the probability for each category, while H1 says some or all are different. So what H0 will say is it'll say P sub 1 is equal to 0.072. P sub 2 is equal to 0.136. P sub 3 is equal to 0.671. And P sub 4 is equal to 0.121. First category, second category, third category, and fourth category. That's what those 1 through 4 apply to. And then H1 says some or all are different. So some or all are different. Well, our claim is that they're the same. So our claim matches H0 in this problem. Okay, that was step 3. See if a claim matches H0 or H1. Put observed into L1, expected N times P into L2. Well, observed is right here, so this is going to go into L1. Now for our expected. So our observed is going into L1. That's our 47, 75, 288, and 45. Our L2 is the expected, which is N times P. Now N you get from adding these together. So I got 47 plus 75 plus 288 plus 45 gives us 455. So that's our N. So then our expected, we're going to take each one of these percentages and multiply times 455. So this will be 0.072 times 455. This one will be 0.136 times 455. This one will be 0.671 times 455. And this one will be 0.121 times 455. 0.072 times 455. You want to round like normal, so that'd be 33. You can't have decimals in expected. Can't have like part of a person, for example. 0.136 times 455 will be 62. 0.671 times 455, 305, and 0.121 times 455, 55. Okay, so we'll put these in L1, we'll put these in L2, and let's see where that goes then. So press my stat, and then I'm going to go into edit. I'm going to clear out those numbers. And we got 47, 75, 288, 45. And then go over to L2, and you got 33, 62, 305, and 55. Okay, and I'm going to exit out, so I do second mode. And that was step 4. Put observed into L1, expected n times p into L2. And now it says find p-value. And we're going to use the chi-square goodness of fit test. Degree of freedom is number of categories minus 1. Number of categories. Well, we have 4 categories. So our degree of freedom is going to be 4 minus 1, which gives us 3. Okay, so come over here. I'll press my stat. Left arrow test. Up arrow. Until I see the chi-square goodness of fit test. I press enter on it. Asks us for observed, which we put into L1. Expected, which we put into L2. Degree of freedom, we just said was 3. And then I'll choose calculate. Then we get P is equal to 0.0096. Okay. Alpha is 5%. So this says that p-value is less than alpha. Well, p-value is not even 1%, so it is less than alpha. That says we're going to reject H0. Although we don't need it, that means we're going to accept H1. Reason why we don't need it is in this problem our claim matches H0. So whatever we say about H0 is what we say about our claim. So we rejected H0, so that means we'll reject our claim. Now, that was shown on the calculator. I'm also going to do the same problem, showing it by hand. And there's a reason for that. Not every calculator has that chi-square goodness fit test on it.